We're going to continue with rational functions, but our new function is f of x equals 2x plus 4 over x minus 1. So there are 3 steps we got to find in order to graph a rational function. We got to determine if it's px over qx, which is true because 2x plus 4 over x minus 1 is in fraction form. And then we got to find the VA and the HA, and then we got to test the point to figure out which direction it's going. So first I will find my VA, our vertical asymptote. So you have to find the VA, you look at the denominator, and I'm going to write it on the left. So our denominator is x minus 1. And then we always set that to 0. Okay, so next step, gotta solve for it. So you add 1. So x equals 1, right? So our VA is x equals 1. Now we gotta look for horizontal asymptotes. To find the horizontal or the HA, you have to look at the highest degree. So the numerator, we only care about the 2x, right? We don't care about the 4. And then the numerator, we care about the x. We don't care about the minus 1, so it's 2x over x. Now, they both have a degree of 1, 1, 1, but we don't really care about the degree, we only care about the coefficient. So on the numerator we have 2, and the denominator we have an invisible 1. So our HA y equals 2. Now we must plot it. So here's vertical asymptote is 1. So here's 1. So make that little dash line. And our horizontal is 2. So here, go on the y-axis. Here's 2, and then make the dash line. It's not perfect, but okay, so now we got to figure out on the right side, right here, which way is it going to go? Is it going to go this way, that way? I don't know. So you got to plug in points. So I will not use 1, right? Because you can never cross the vertical asymptote. So I will use 2. So I will do f of 2 equals 2 times 2 plus 4 over 2 minus 1. So that equals 2 times 2 is 4 plus 4, which is 8. And then 2 minus 1 is 1. So our coordinate would be 2, comma 8. So let me plot it. So here's 2, and then 8 is 1, 2, 3, 4, 5. So here it is. So it's going to look something like and it will never touch. Okay, now we got to figure out what our right side looks like. So let me just erase. Okay, so I will use first I will use -1, right? I put -1. So 2 times -1 plus 4 over -1 minus 1, right? So 2 times -1 is -2 plus 4, which is +2. And then -1 minus 1 is -1. I mean -2. So that's just -1. And that in coordinate form, it would be -1, comma -1. So here's -1 and -1. Okay, I'm not really sure. Since I'm not really sure how it'll go, if the horizontal was 0, but our horizontal is 2, I would know it would go like this. But since it's a little bit upwards, I gotta plug in more points to be more accurate. So my next point will be -3. I will choose -3. So it's 2 times -3 plus 4 all over -3 minus 1. And that should equal, okay, so 2 times -3 is -6 plus 4, which is -2 over -3 minus 1 is -4. And that is reduced to +1/2, right? So our coordinate would be -3, comma 1/2. So here's -3, and 1/2. Here's 1, so it'd be right there. So it will look something like this. And you can add more points if you want more accuracy, but all I need is just 2. So it doesn't go straight up like this. It kind of curves, right? The problem doesn't ask you the domain and range, but I could just tell you. So the domain would be from -infinity to 1, right? And then union, parentheses 1, comma, positive infinity. And the range would be from -infinity, right, to 2, and then union to positive infinity. And that's how you graph a rational function.